Hello everyone. In this video I'll be showing you how I made the control board for my robot Jumpy. So this is the schematic, and this is the TNZ 3.5 microcontroller. I have attached IMU, GYT7 and SD data logger, a screen. These pins for servos which are connected to the joints. Some pins for the power supply, 5 volt and 3 volts, in case I need in future. And these are the IO pins which are not used as of now, but like I want them to be there if I want to attach any other peripheral in future. So these are three are the power pins 7805, because I want to servos to be the high speed and running at the full voltage. But this IC needs 7.5 volts, so for that I have 7805 IC and some analog pins separately, in a three wire system. So the schematic is converted into the PCB. I have already made tutorials on how to make the PCB and the schematics in Altium. So I have this PCB ready. Now it's time to take the output files as a Gerber files and drill files for the final PCB design. So before I proceed with the fabrication output here, I need to make sure which layers I want. I'm using top overlay, bottom overlay layer, and the bottom layer, and the bottom overlay layer. So I've got like these three layers. I'm not using any board cutout layer because my dimensions of the board are already set with the CNC. I know the dimensions of my board, so, and the PCB is inside that board, so I know that it will not exceed the limits. Okay, and this one is important. The bottom layer is mirrored, and for the final design, this is very much important. I'll be making another video where I made the mistake where the bottom layer is not mirrored. So the reason it is necessary is because the CNC machine makes the PCB from the copper side of the board, and we put the components, all these devices like the TNC board and the IMU, from the insulated side of the PCB board. So you can imagine that that when we flip the board, all the pins get flipped as well. So um, either you will be, if you print the board like this as shown in this figure, you will have to put the components from the copper side, which is not done usually, and it's not recommended. We put the components from the other side, so the pins get flipped. Okay, so either you flip this copper layer, the bottom layer, or you need to flip the components and then put from the insulated side of the PCB. I'll be making another video where I describe all this. So in short, you need to flip the mirror this bottom layer, and I will keep all the other things as they are. The resolution is 4:4. So you can see the top overlay is the yellow lines, and the blue lines is the bottom layer, the actual PCB tracks. So if I show you the PCB, the unmirrored version, it looks like this, and the mirrored version look like this. So this is my final design, and I have this top overlay and the bottom overlay. The bottom overlay is here, and technically I'll be using this layer separately with the CNC machine, and I'll show you that I'll be dragging this text to the empty part of this copper side of the board, because The top overlay will be printed onto the top side of the board, the insulated side. But this bottom overlay, I want to print it onto the copper side of the board, so it has to be at the proper location. Okay, so once I have this, I'll be going back to this PCB design and drill files. Select the units, absolute origin, okay, and okay. I've got the drill holes here. So all these files are now in this folder, the project folder of my Jumpy's control board PCB design. Now the second step is to go to the flat cam. Here I'll be opening up the Jabber file. The Jabber file is my bottom layer. So here's the bottom layer. So flat cam, your origin is here. So wherever you put your board, your CNC machine will think that your board is there. So I'll have to reposition this board properly. Move. Select the corner and place it to a proper location like this. Make sure your tracks stay clear of these lines, the origin lines. Okay, so this is here, and I'll select this. Go to selected, tool style. I'll go to calculators. Point 2 tip 30 degrees, and the cut size is minus 0.2. And if I do minus 0.2, my tool die is 3.3. If I do 1.5, it's 2.5. Okay, I'll do minus 2. Copy. Paste. So the reason I did the calculator is because my actual tip diameter is 0.2, but the tip angle is 0.30, and based on these calculations, uh, the tool die would be, and the CNC has to take the tool die as a 0.3 because of the angle and the cut angle of the drill bit. I'll do one pass and generate isolation generator. Okay, so this is it. The red lines are the lines where the drill bit will move, and you can see that this part will be left out. So here, and there will be some copper left. Okay, so you don't want that. So to remove the more copper, I'll delete this. I'll do at least 2 passes with a 40% overlap and isolation geometry. Now you can see the drill bit will move along all these lines. Okay, so this will most probably remove most of the copper from the spaces in between the tracks. Okay, so cut size is minus 0.2, travel 2, and move is 5 millimeters. X5 feed rate, I prefer a bit higher. Spindle speed is 1000, like this. Okay, double check and generate a CNC job. And this I would want to view the CNC code. So S100 is the spindle speed, minus 0.2, and it's good to go. I'll save the code. New G code, GBL, like this. This is done. Okay, and this is the final G code. this is extra file, so I'll just have this one. Okay, now I'll be getting another file, which is the bottom layer. GBO, and the GBO is here. So I need to put it at the proper location because it will be printed as at the location wherever it is shown here on the PCB. Okay, so okay, I think I need to rotate this one. Go to option and rotate selection, rotate 90 degrees, so like this. Here. So Jumpy 2.0 and like this. Okay. Now again, I'll select the tip die of like 0.2. The precision in here, I'll not make it super precise. So I'll just take like this. Geometry 0.2 and move is 515. Create a CNC job. View the code. Okay, I need to set the spindle speed 1000 and -2. Okay, okay. Use CNC code -2 and it will start working. Okay, this is code number 2. I'll save this code and file design G code. This is GBO, second file to run. Okay, and I've got like the third important file, which is tracks, the drill tracks. Okay, so the drill tracks are here, but I know that I flipped the board, but the drill tracks are not flipped. So while selecting this layer, I'll go to option, flip on x-axis. So the tracks are now flipped, and I'll right click, move, and it should be good here. Okay, not good. Move. Okay, looks good. So for some reason the holes are not very much aligned. I've yet to look into that matter. I have tried zooming in, but like still the holes were not properly aligned. So I'm still okay with this display and the hole placement, because my CNC machine is not very much precise. So the holes are drilled at a little bit aside, the side of the copper will still remain for the soldering. Okay, so this is the third file and the alignment is good, and while it's selected, I'll say the cut size is -2 millimeters, travel is this, and move is 5 millimeters. Okay, spindle speed is 1000. Okay, and the tool dia is supposed to be 0.9 or 0.8. My hole size are like 0.9, but like my tool that I'll be putting into the spindle will be 0.8. So it's a 0.8 just here. Okay, so create the drills G code. We use CNC code spindle, and every location it goes -2 from the home location. Okay, so this is the third file I'll be running. I'll be saving this code, new code, and so bottom layer, top, bottom overlay, and the sorry, change the name. And the third file is txt. I would prefer it drill CNC. Okay, so I have now these 3 CNC files which will help me to finish my CNC job. Okay, so once I'm done with the flight cam, all the G codes, it's time for the G code sender. So I'm using this software, Universal G code sender, and the first thing that you would do in the G code sender is connect your machine. And when you connect your machine, make sure you have your COM port. Okay, so once it's successfully connected, you will see here. And the first thing you would do in here is do the $sign and see the settings. And setting number 21, you should set the hard limits to 0. So disable the hard limits and make sure you're working with your allowed working area on your CNC. So the reason is because I have this machine which is DIY and it's not super precise, so I've seen that sometimes it just automatically gets triggered with the hard limit, the false noise signals. So once it's triggered, the machine stops and you'll have to start from scratching. So I just keep it disabled and just make sure be extra careful on the other side in the actual hardware side of the machine. Okay, so this is good. Another thing is that set your home location. So wherever your spindle is, you have to move with your this jog controller and then double tap on these 3x, y and z, and it will tell your software that wherever your spindle is, that is your home location, and your PCB will think that this yellow point is there. Okay, so let me open. So here is my all G codes that I just created with FlightCam, and the first layer I would want to go is here, the bottom layer. So once it's loaded, you can see the dimensions of your PCB. You can see that this is the flip mirrored board. You have your PCB tracks in here, and yeah, looks good. Okay, just to give a little bit check that your code is all right, especially the z-axis. That will depth that the drill bit will go inside. Okay, so now I have to set my CNC and set up my board, and then all I need to do is just to set the home location and press the send button. So this is the PCB, and I'll just remove the tabs. So here goes my PCB to that direction. So the way I set the space between Z axis, the drill bit, and the PCB is to take a piece of paper and The gap should be such that it can easily move in between. Not easily, but it can scratch a little bit. So you can also see the shadow of the little bit, and that's a little bit higher. So it's probably 0.1 millimeters above the PCB surface, which is considered to be the home location of the Z-axis. So my PCB is ready and it's coming towards me. Let's move it away from the spindle, and I used a double tape. Be careful not to. Oof. So this is beautiful PCB that I just created.